Good day, everyone. I'm Daniel Adediran, a research assistant at Ellis Biogen Institute. I'll be presenting on my project Computational Design of Messenger RNA Vaccine Against Lassa Virus Infection at Beyond Science Initiative Conference. Lassa fever is an animal-borne or zoonotic acute viral illness that is commonly spread by African rats. So the first case of Lassa fever was documented in the year 1969, and it was named after a town in Nigeria where it was first discovered. So about 100,000 to 300,000 infections of Lassa fever occur annually, with about 5,000 deaths each year. Surveillance for Lassa fever varies between locations, so these estimates are crude in determining the effect of the Lassa virus in a particular location. So it is very endemic in part of West African countries. Neighboring countries are also at risk because the animal vectors live throughout the region. The African rat lives throughout the region. That's why it is very endemic in all West African countries. So our research aim and objective is to design a candidate vaccine that has a long-term effect of combating Lassa virus infection, because there is no available treatment of vaccine that has been approved to treat or prevent this Lassa fever. So these are the methodology that we use in designing this mRNA Lassa vaccines. So the first thing we did is to retrieve our target sequence from NCBR and Viper. So we then carry out CTL prediction using NuCTL server, HTL prediction to get our HTL epitopes using IEDB MHC2 server. The B cell prediction as well was carried out using the BBPRED servers. Furthermore, all these epitopes are combined together to form our candidate Lassa mRNA primary construct. Furthermore, the primary construct was the physiochemical properties of the primary construct was done using NSPACY post-program tools. So as well, the secondary structure prediction of the primary sequence of our messenger RNA construct was done using the SOAPMAN server. The tertiary structure was also done using the ITASA. So also, the downstream analysis of the primary construct, such as the antigenicity, allergenicity, toxicity, was also done to assess if a vaccine is antigenic, non-allergenic, and non-toxic. So also, the molecular docking of the tertiary structure was done. So also the normal mode analysis of the construct was done. The primary construct was also reverse translated to the mRNA. Then the codon adaptation was done, and the computational cloning using SnapGene was also carried out. So these are some of the results. The result shown here is the primary construct, the HTL epitopes combined with LBL epitopes, the CTL epitopes, and some other adjuvants and signal peptides that will make up the few molecules of these Lassa messenger RNA vaccines. So the shown here below, figure 2b, is the secondary structure showing the presence of alpha helix and beta pleated sheet and the number of amino acid residues that are present in the chain in the construct. So this is the physiochemical properties of the designed Lassa messenger RNA vaccine. The molecular weight 251.7 kilodalton, showing that the molecular weight is still okay. The estimated PI is around 8.47 and the instability index is 49.63, showing how stable the mRNA is, how likely unstable it is. The aliphatic index is 67.16, and the ground average hydropaticity is around minus 0.489, showing that it is hydropathic in nature. So also the assessment of the messenger RNA LASSA vaccine, it was found to be antigenic at a score of 0.5420. It is non-allergenic and it is non-toxic. So this is the data structure of the messenger RNA LASSA vaccine as shown in the figure 3A, and also the Ramachandra plot score show that the messenger RNA vaccine is present in highly favorable region. The construct is in highly favorable region of amino acid site. So the tertiary structure was done with different toll-like receptors, toll-like receptor 2, 3, and 8, to assess the interaction between the design construct and the innate immune receptor we call toll-like receptors 2, 3, and 8. So our results show that the construct, the vaccine, LASSA messenger RNA vaccine, has a high binding affinity for toll-like receptor 9. Looking at the binding score below, which is minus 1176.10, because the lower the binding score, the higher the affinity for the interaction between these molecules. So this toll-like receptor 9 was chosen to carry out the normal mode analysis. So the normal mode analysis results shown here indicates that the construct, the messenger RNA construct, has high interaction. It is very stable, has high interaction with the toll-like receptor 9. There's a stable interaction between these two molecules. This is what the normal mode analysis is showing. So the immune simulation of the LASSA messenger RNA was also done using tools called the ICSSIM tools to carry out this. This was also done to know if the messenger RNA vaccine we design will be able to induce immune response at the end of the day. So our results show that there will be high concentration of all innate and the adaptive immune cells, showing that this vaccine will highly induce immune response. So as said earlier, the physiochemical properties of the construct is projected the efficacy of how good it is as a candidate vaccine for LASSA infections. So looking at the molecular weight, which is around 251.7 kilo, which is very similar to the work done by Oladipo et al. So, and the basicity of the construct was revealed through theoretical PI, while the stability expressed showed that it is the messenger RNA we design is unstable in nature, but there is more to it to be done so that the messenger RNA vaccine can look stable. As we all know that most messenger RNA are not stable in nature. So for this construct further depicts the instability of the protein upon expression, and the aliphatic index show that the thermostability of the vaccine, how stable it is in the presence of temperature. So, and the ground average hydropathy depicts that it is hydropathic in nature. It will be able to permeate the membranes, so which is a good factor. So in conclusion, the overall reverse vaccinology approach has shown the candidate LASSA mRNA vaccine to be proven to fit necessary criteria in combating this LASSA infection, and therefore further validation via in vivo and in vitro techniques and some preclinical trial approach need to be conducted to show the efficiency and potency of this candidate LASSA mRNA vaccine. So our future prospect is to have a vaccine, LASSA mRNA vaccine that will eradicate all this LASSA infection, especially in African countries, and we hope to achieve this in the nearest future. So my acknowledgement goes to my team member at Ellis Biogen Institute and Beyond Science Initiative for giving me this opportunity to come and talk on our work on designing a messenger RNA vaccine for LASSA using in silico approach. Thank you for listening, and if you have any questions, you can email me and you can also message me on LinkedIn. Thank you for listening. Goodbye.